Hey guys, so this is going to be our video explanation of the Beer's Law lab. So first off, what exactly is Beer's Law? Well, basically Beer's Law says that whenever you shine light through a solution, some of the light doesn't make it all the way through. More stuff you have in the water, less stuff gets through. Less light gets through. That's basically it. That's the short version of it. But let's get into the long version of it, shall we? So this is this idea. You have this thing called a spectrometer. Spectrometer is this instrument. It's a machine that has a light source. So this thing is a light source, right? There's a prism in it, okay? And then there's going to be your sample, your solution sample. There's my test tube with stuff in it. And then there's some sort of detector here. This detector detects photons. Okay, and that's basically it. So what this machine does is light will go through here, pass through here, and once it hits the prism, it's going to scatter the light. It's going to make the red light go this way, then orange, then green, then blue, then violet, so on and so forth. What we can do is rotate this prism so only one type of light is getting through here. Let's make this orange light. So we got orange light going through. All right. So orange light is going to be going through, and it's going to be shining through this this sample, this solution that we have made. Now, this solution in it has some kind of salt in it. The salt that we're going to be using is copper sulfate. Copper sulfate makes a nice blue solution, so you can actually see, oh, it's a really dark blue. This must be a very concentrated solution. Oh, this is very light blue. It's not that concentrated at all. So what's going to happen is when this light goes through, some of these ions that are inside of here will absorb this light. We'll talk about why they're absorbing light on Tuesday, but some of these is going to be absorbed. So less light actually makes it through. Some of this light goes away. So, and then this photon detector will detect how much there is. So, if we want, we could go through, put in a crystal clear water sample in here. Now, water is going to absorb some of this light as well, but we can put in that water here and read how many photons we have. Then put in our copper sulfate and see how many are in there. And basically at that point, we're going to have our the intensity not over the intensity of our sample. So this is kind of our without the salt, and this is with the salt. And that's going to get us something called an absorbance. Absorbance. This is how much light did our salt absorb. So this is going to be pretty useful, because you can imagine if we have a huge concentration of our salt in here, what's going to happen to the absorbance? If we have a lot, that means that we're going to have more light being absorbing. So in terms of our concentration, if our concentration goes up, the absorbance also goes up. So that's great. Awesome. That's pretty cool. What are some other things that can affect this absorbance? Well, what happens if we just put in a bigger test tube? Like instead of, let me redo this. So instead of a thin test tube like that, what happens if we have a big fat test tube, right? Well, if the light's traveling through more of this, it's going to absorb more. So the actual length of our test tube will also affect this. So the longer, the more width our test tube is, this is denoted as L, the longer this width is, the more it absorbs as well. So we have to take that into account. There's one other thing that we have to take into account, and that is what the salt is itself. So every salt is going to absorb things a little differently, and that quality is going to be called epsilon, E, epsilon. And Beer was a dude that went through and studied this, and he came up with this right here. This is Beer's law, that the absorbance is how much light actually passes through our sample can be determined by three things. One, what the sample is. Is it copper sulfate solution or sodium chloride or any other thing that we put in there? Sugar, how much sugar is in there. And so that's our epsilon, what the thing is. The concentration of it, the more we put in, the more it's going to absorb, which that makes sense. And then the length of our test tube. So if we have a really skinny test tube, that L, that width, is going to be a lot smaller. And so if it's really long, if it's the wider our test tube, the more it absorbs. Again, that kind of makes sense as well. So those are the three things that we can go about and figure this out. So what are we going to be doing? Let me clean this up. On Thursday, this is what we're going to be doing. You guys are going to be all making a bunch of copper sulfate solution. You are going to be doing it yourself, which means that you're going to need to determine how much mass of copper sulfate pentahydrate are we going to have. We're not going to have just copper sulfate. It's going to be copper sulfate pentahydrate. So remember, it's going to be that. So you're going to have to figure out how much of this you're actually going to need to fill up the container I give you. I'm going to give you a volumetric flask. And a little volumetric flask. And I think it's going to be 250 mils. So you'll need to figure out how much to weigh this out and make this solution. That's going to be step one. Step two is going to be this finding E part. Now, I already said here, wrote this down, it's going to be 0.5 molar copper sulfate, which means you guys are going to have to do the following. You are going to go through and use a spectrophotometer. We have little test tubes. They're called cuvettes. And I'll explain more about this later. I'll explain it now. There's two sides to these cuvettes. There's a rough side and a smooth, clear side. They're made that way to let you know that, hey, this is the rough side. Don't shine the light through the rough side. Shine it through the nice, clear side. That's the side that was kind of made to be perfectly smooth and without any imperfections. So use that side. You're going to fill up this cuvette with pure water, stick it into our spectrophotometer, and calibrate it. That's how we're going to go through and calibrate the spectrophotometer. There's a nice little button that you just hit to calibrate it. Then remove the cuvette, clean it out, put in your copper sulfate at 0.5 molar, and stick it back in, and you will get an absorbance. So now we have the absorbance. Let me rewrite this real quick. Concentration and length. All right, so yes, we have the absorbance, right? You know the concentration is 0.5 molar. And you know that this length is going to be 1 centimeter. All these cuvettes are exactly 1 centimeter across. So length is going to be there. And from that, you should realize at this point, we can use this to calculate E, to find what E is for copper sulfate. What is epsilon? This is the absorption coefficient, if you want to be all fancy and use fancy words. Yeah, so epsilon is going to be the absorption coefficient, and we are finding the absorption coefficient for copper sulfate. That's going to be our first goal. Okay. Second goal, make a Beers plot. What is a Beers plot? Well, a Beers plot, I can show you real quick. Beers plot. This is a Beers plot. Okay. This is a Beers plot. Let me blow this up. There's two sides to it: absorbance, concentration, and there's that. So you would imagine that, if we take the absorbance at concentration 0.6, we're going to get something, right? Then you lower the concentration. You dilute your sample. So once you lowered the concentration, diluted your sample, you're going to take another reading, another absorbance, and plot that out. And then you're going to lower the concentration again, make another dilution, take another absorbance reading, and then do it again, and then do it again. And when you do that, it makes this nice straight line. This straight line is going to be very helpful to us in determining concentrations of unknown, or samples of unknown concentration. So you're going to make this plot out. What do I mean by it's going to be helpful for unknown concentrations? Oh, geez, it's really big. Oh, well. Let's say I have an unknown concentration. I know it's copper sulfate. I don't know what the concentration is. My lab partner just handed me the vial and said, here you go, there's some copper sulfate. And I'm like, did you get the concentration? No. Ah, geez. So let's say I go through, I put it in the spectrophotometer, and I get an absorbance of 0.4. Okay? Then I can just draw a line here, and then draw a line down. And I know that this concentration is now about 2.4 or 0.24. And there we go. That is why Beers law plots are so nice. So there's that. Let's go back here. To make a Beers law plot, you're going to have to make something called a dilution series. So what is a dilution series? Well, you have your 0.5 molar copper sulfate here, right? We don't want just 0.5 molar. We need to get a lot of different molarities. So we have 0.5 molar. We're going to have a bunch of other test tubes. Okay. So what we're going to do, we have our 0.5 molar here, and we're going to start with 10 mils of it. Okay. We're going to take 1 milliliter out of here and place it in here. All right. Then we're going to fill this up with 9 mils of water. All right, so what did we do just there? We made a dilution. We have lowered the concentration. So that, just so you know, we'll go over this a different time, but we have something called M1V1 equals M2V2. So this is the molarity of the first sample. The volume of it is always going to equal the molarity of the second sample and the volume of it. So I took 1 mil of 0.5 molar and I made it into a 10 mil solution. So what is this new molarity going to be? We'll do a little bit of algebra. 0.5 times 1 over 10. What is this going to be? Well, 0.5 divided by 10 is going to be 0.05. There we go. So this is how we're going to go through and make a dilution. We're not going to do one dilution, though. We're going to do several dilutions. And we're not going to do a 1 to 10 dilution like this. Okay. We have our... Whoop. Let me make these a little bit bigger. 1, 2, 3, 4, 5. We're going to do a 1 to 2 dilution. So we're basically going to half it each time. We have our 10 mils to start with. We're going to take 5 mils out and put it in here. And then fill this up with 5 mils of water. So then also 5 mils of H2O. And then we're going to shake this up, make sure it's good and mixed, and then take another 5 mils and put it in the next one. And then also 5 mils of water. And then we're going to do the same thing, and we're going to do the same thing. So what are all these concentrations going to be? Well, the first one is 0.5. The second one's going to be 0.25. This one's going to be 0.125. The next one, fourth one, is going to be, what is that? 0.625. And then the last one is going to be 0.3125 molarity. So here we go. So we're going to have all of these points. Okay. Now we have 5 different samples, and you're going to find the absorbances for all of these. This is the molarity, and then you're going to find the absorbance for each of these guys. I'm already making a little spreadsheet. And when you go through, make these absorbances, you're going to put them into a spreadsheet. This spreadsheet is then going to turn into one of these Beer's plot plots. And there is your Beer's plot. Congratulations. You now have the ability to find any concentration of copper sulfate that I can give you, which is going to be a good thing, because on Monday, I'm going to give you an unknown concentration of copper sulfate, and you're going to use your Beer's law plot to tell me the correct concentration. This is going to be pretty easy. I'm literally just going to hand you a test tube that's labeled 1 through 32, and then you're going to take it, suck it up, put it into your spectrophotometer, find the absorbance, and then since you found the absorbance, you'll go from 0.4. If it's 0.4, you'll go down and say, it's 0.24, and you'll get credit for your hard work. Good job. And that's basically it. As for what it is, I want you to go through and do, it's going to be these following things as far as lab reports go. You should always write your recipes down whenever you're making a solution of any kind. You only have to do this once. So typically in a lab, you will have kind of a recipe book, basically a standard procedure for making a solution, a copper sulfate solution, or there's all sorts of different buffers and things like that. TAE, TBE, all of these different things. So you do need to write it down in your lab notebook though. But the great thing is you only have to write it down once, and every time you ever refer to it, you can just refer back to it. You don't have to say, I made a new solution, and here's how I did it every time. So you do have to write it down once though. So you are going to be doing that. Finding epsilon, finding that coefficient. So here's this. Same thing. You won't be doing any, this is another one of those finding things. So you won't actually be writing hypotheses for this. Making a Beer's law plot. There will not be a hypothesis related here. And then finding the coefficient of the unknown. This one's going to be pretty simple. Just tell me your results, and we'll see if you're right or not. Don't worry about these numbers. These are last year's numbers. I need to change them with how I'm scoring things this time. It's probably going to be about half. So instead of our typical 25 point lab. This is a little bit longer, so it's going to be a 50-point lab. I'd basically just imagine just half all these numbers. Okay. And that is going to be it. There's not going to be any real hypotheses on any of these things, so don't worry about that. All right. And that's it. It should take us a few days to do. If you have questions, which I'm sure you will, you can get a hold of me through the normal means. And I will see you guys, not tomorrow because it's Distance Day, but I will see you guys Tuesday. All right, bye.